3.7 is elasticity of demand. If price and demand are related by x equals f of p, then elasticity of demand is given by E of p equals negative p f prime of p all over f of p. Okay, so whenever you're working with the formula, you'll always start it off with negative p, then you'll take the derivative of the function that they gave you and divide it by the original function. So let's take a look at a few examples. Use the price-demand equation to determine whether demand is elastic, inelastic, or has unit elasticity at the indicated values of p. In our first one, we've got x equals f of p equals 12,000 minus 10p squared. And we're going to figure it out for p equals 10, p equals 30, and p equals 20. Well, first of all, let's go ahead and figure out what E of p is. So we'll use our formula. And we're always going to start off with negative p, and then we'll take the derivative of our function. So we're taking the derivative of this. This is just a constant, so the derivative of that is 0. Take the derivative of this, 2 times 10, we get negative 20 p to the first power when we subtract 1. And then we divide it by the original function. I like to simplify it a little bit at this point, but you don't have to. You could just use it like this. I go ahead and multiply negative p times negative 20p. That'll give me a positive 20p squared. Then it's just a little nicer when you're plugging in the different values. Okay, so let's go ahead and plug in 10. So part I, E of 10 is just going to be 20 times 10 squared all over 12,000 minus 10 times 10 squared. And then I did it ahead of time, so when I put this in my calculator, I got 2,000 on top and 11,000 on bottom, which gave me 0.1818. Okay, and there's a chart on your notes on Canvas that tells you what it means to be inelastic, elastic, or unit. This one's an example of an inelastic problem. And you'll see on the chart that that meant that E of p is in between 0 and 1. Okay, since we got 0.1818. And I'll expect to see this number on your homework and what it was, inelastic, elastic, or unit. Okay, so even if it's a multiple choice test, you'll need to make sure you know the number and which one it is in order to find the correct answer. Okay, let's do the other two. So we'll plug in 30. Which will give me 20 times 30 squared all over 12,000. Whoops, sorry about that. Minus 10 times 30 squared. Okay, and then I got 18,000 over 3,000, which gave me 6, and that means that one's elastic when E of P is greater than 1. Okay, and finally we'll plug in 20. So we've got 20 times 20 squared over 12,000 minus 10 times 20 squared. And when I did that one, I got 8,000 over 8,000, which of course gives me 1. And that one's an example of unit. When E of P equals 1. Okay, so let's just do one more so that we can practice finding E of P. So I've got x equals f of p equals 950 minus 2p minus 0.1 p squared. And we're going to find p equals 30 and p equals 70. Well, let's first start by finding E of P. Always start off with negative p, and then we're finding the derivative of the original function. Again, the derivative of a constant is 0. The derivative of this would be negative 2 minus, okay, here we can do the power rule, so bring the 2 down. 2 times 0.1 is 0.2 p, and subtract 1 will give me a power of 1. All over the original function okay, and again, you can leave it like that, or you can simplify it so that it's a little easier to plug things in. I'm going to go ahead and distribute. So negative p times negative 2 is a positive 2p. And a negative times a negative again will give me a positive, so I put a plus 0.2p squared. All over the original. And I might just point at it so that we don't have to rewrite it. I don't think I have enough room there. Okay, and let me just write down what I got for each of the two parts. So for E of 30 here, when I plugged it in, I got 240 over 800, which gave me 0.3. And of course, that's an example of inelastic. And then for E of 70, when I plugged it in, I got 1,120 over 320, which gave me 3.5. And that one's an example of elastic. Okay, so you should definitely plug them in yourself and make sure that you get these answers. If you have any trouble with your calculator, make sure you talk to me or email me. And in the notes, I also put some more examples at the beginning of just practicing using this formula. So if you need more practice using the formula, check out those examples. And if you have any trouble with your calculator, email me. All right, talk to you later.